Thank you for joining today for our SunLink Filling in the Blanks, How What Your Data Monitoring Isn't Telling You is Threatening Your Financial Returns webinar. Today we have two different speakers. We have Mr. Jonathan Eastwood and Ms. Kate Trono. Jonathan brings over 12 years experience in the solar renewable industry, from engineering to development to sales. And Kate is leading the product management for our roof, tracker, and fixed tilt mounting systems, as well as leading the growth for our Power Care Services division and managing our Tech Hub team. I want to briefly go through the agenda with you as well for today. So we will be providing some definitions of some of the terms we're going to talk about, a project example to review, some SCADA and DAS challenges, some NTech convergence solutions. We'll review the solar market, and we'll end with some Q&A. And so if you have any questions at any point throughout the webinar, please feel free to submit that through the chat function, and we'll get to that at the end. At that point, I'd like to go ahead and turn it over to Jonathan.
Thank you, George. All right, so what is SCADA? We just want to cover the basics real quick. So SCADA and performance monitoring solutions are used for different purposes. And SCADA stands for Supervisory Control and Data Acquisition. They're computer systems used for gathering and analyzing real-time data. And they're used to monitor and control plant or equipment in a wide range of industries, such as telecommunication, energy, transportation. Within the context of the solar industry, these systems are typically required by the utility or the ISO of the solar plant interconnecting, and so that they have direct control capabilities. Smaller solar systems, they don't typically have the full SCADA requirement, and in these cases, the systems are generally equipped with a basic performance operational monitoring package, which is purely data acquisition, and it doesn't have a lot of controls or intelligence built into them. So why is SunLink focused on SCADA? So over my 12 years in the industry, I've seen a wide range of advancements, but I've seen little with respect to the advancement of operational monitoring SCADA systems. So while working for a developer owner, my experience was that operational monitoring SCADA was just a very frustrating experience all around. There was a lot of proprietary technology solutions that were custom in application, they were expensive, they were layered, and they didn't come with a lot of support. So that's why I'm really excited about what we're doing here. As a solar energy solutions provider, SunLink identified monitoring and SCADA as a major pain point for solar plant stakeholders. So with that, we took a step back and we looked at the traditional approach and decided there was a better way to do it. And the first step was to consider all the various key stakeholder requirements in the context of one system. So that would be the developers, EPCs, asset managers, O&M providers. So they're all looking for different tools to support their respective scopes. And with that in mind, we decided that we wove together these disparate layers and created a cross-functional platform that improves solar plant intelligence, but also one that stimulates broader innovation in the solar industry. So, currently, SCADA and operational monitoring systems, they're a major touch point with the customer, but do not typically reflect the operational efficiency of the system, and the EPCs have little control over the data and how that translates into useful information. So it's one of the most integral parts of a successful system deployment, but is also one of the last items to be considered. Current operational monitoring systems, they have a lot of data, but it's difficult to translate that into useful information. And asset managers are typically, they're pulling a massive amount of data manually in order to turn into useful information. So we want to try to automate these systems, and as the penetration of renewables increases, this will become increasingly important. The other issue is that people are using a lot of proprietary systems. And when you have proprietary systems, there's no cross-pollination. Developers are not taking advantage of what's readily available and utilizing that across their platform. They're developing everything internally, and it's all customized in application. And it's just very inefficient. Also, when looking to the future, a lot of SCADA implementation is custom, it's slow and costly, so we need to streamline this process. And generally, these are not scalable solutions. So right here is an example. I mean, you can see we have the ability to manage a broad portfolio of assets and to quickly determine which assets within that portfolio are having problems depending on their color. So the size indicates how much of a portion of the energy yield that particular system contributes to the portfolio, and then the color is indicative of whether or not there's a problem with that particular project. So this is just an example of some quick analytics that would come with the platform we've developed. So this jumps into the solution we've developed, which is the Vertex solution. So with the convergence of energy and technology, we can already see a new wave of innovation broadening the solar plant intelligence and performance. And this innovation will be integrated in the solar plant hardware, the operational monitoring, and the SCADA systems. So looking ahead at this convergence, we developed a project intelligence platform that combines the tools utilized in both tech and the finance industries, and that is this Vertex platform. So the platform is designed not to only support our own products and services, but also to support others as well. We see Vertex as the platform that will integrate the next wave of products that are introduced as a byproduct of a higher penetration of renewables onto the grid. So for example, with energy storage, frequency regulation, these are all components of distributed energy generation that will play out and will need to be managed and controlled through one platform. So some of the benefits of Vertex is we really considered all the various stakeholder requirements within the context of one platform. We looked at developers, their requirements, EPCs, asset managers, and we took all of their various customized systems and we integrated them into one platform. And so that really empowers operators with powerful functionality depending on the functionality they need. So instead of creating a new layer, it's integrated. It's just that they come to us and they say, what kind of functionality do you need? And then we can implement that functionality. The REST API is a major benefit. It really encourages developers to create applications that increase the penetration of solar and other renewable technologies. We will have, Kate will go into the REST API in a little bit more detail, but just some examples is that an API would allow integration of an S camera, for example, within the Vertex platform. And as other requirements come out from utilities, for example, just frequency regulation or reactive power control through the inverter, that can all be managed directly through the Vertex platform. And at the heart of this is strong cybersecurity. So we want to empower the right people and to protect the assets we are building from the potential of being compromised. And a big focus of that is in mobile technology, secure mobile technologies. So that would be two-factor authentication, being air gap between the public cloud and the private cloud. Again, Kate will go into this in a little bit more detail, but it is really the heart of it, and it's important that we built that first and it created a strong foundation from which to grow the platform. And also, we're not pricing on a per-device basis. We're pricing just based on functionality, and you pay for the functionality you want. And I think that's really important depending on the stakeholder that you are. Right here we have a project example. So the system on the left was being monitored before Vertex. The system on the right is after we retrofitted the system with Vertex. And what you can see on the left is that there was a trailing in the energy yield, and it was because the tracker has been stalled out for some reason. With the Vertex system, we have the control functionality built in, so we were able to remotely reset that inverter and to avoid as much downtime as possible. In this case, there was a loss of energy of 77 kilowatt hours. And you can also see there's difference in the performance of the inverters. So, having the analytics to try to determine what is the root cause of that difference, is it soiling, is it system efficiency? Generally, being able to diagnose those problems is some of the inherent functionality we have within the system. So now that I've covered, why SCADA and provided a higher level review of the Vertex platform, I'll pass the baton to Kate, and she can go into more depth on the capabilities and functionality.
Thanks, Jonathan. And one thing I would like to note about this project data that's really important, this is for a couple of ASU projects that we've deployed Vertex on. And because Arizona State University has made a commitment to making all of their energy data public, that's what has facilitated our ability to share this data with you and also continue to look at innovative ways that we might optimize energy efficiency based off of not only the analytics we're doing, but also other ways that developers might be able to create new graphing capabilities, new different algorithms that could be innovative beyond what we've done already as well. I'm going to talk a little bit about the data and controls problem and some of the issues that we're seeing not only in solar, but that go across different industries more generally. And so these problems that you'll hear about, they are common to Internet of Things, that industry in general, what people are trying to do with that. They're common to big data. They're common to kind of the ways that companies are trying to shape their futures. These are some of the challenges that people are seeing. So when we talk about siloed data, an example from outside of solar is that people are trying to push the boundary of what we can use sensors on in order to enable people to take action based on what's actually happening in the world at this moment. So one example of that is having sensors on public transit, whether it's buses, on subway, on trains, and as well as intersection lights, and having mobile data for how people are moving about the city in order to get a really clear sense of traffic patterns in the city and how long it would take to get from one place to another based on real-time route comparisons. So you're starting to see this in all of your different map applications that you have on your phone, but it's because of leveraging these different pieces of data that are typically very siloed and putting them together into one application that you can really then motivate people to say, do I drive today? Do I take the bus? What's the difference in terms of time getting from this place to the other? And how does that affect my overall day? From the solar side, when we look at this, the challenge with siloed data is that we have unique logins per SCADA platform. So this is very painful. Every EPC developer, O&M company, everyone has their personal favorite flavor of what they like to use, but with projects changing hands and with different stakeholders involved in the decision-making process at the outset, it's very unlikely that 100% of any one portfolio is on one particular solution. So then this causes different logins for different platforms in order to look at how projects are performing. It's a very siloed process where you have to go in separately to each of these different projects and pull data rather than having that portfolio view pushed to you, as was shown where Jonathan went through portfolio data analytics and how that scales with the number of projects you have. Now if we talk about incomplete analytics from a general lifestyle perspective, one of the companies that I see doing interesting things in analytics is Enlighted. So where they started out putting sensors in lights in order to improve commercial building energy efficiency, they're now taking that data and using their commercial building sensors as a way to analyze how people are moving about in offices. And then from there, which departments are speaking to each other most often, which teams are collaborating the most, and how can we better design our workplaces in order to optimize our workflows that are happening in real life. But this incomplete analytics challenge is a real problem in solar because the limited dashboards that have been developed for solar focus on the what, not the why. So in particular, this is what is the energy, not why is this what the energy is. So the thing that I see when I look across a smattering of different dashboards available in the solar industry is that everybody will tell you what your energy is on varying granularity scales. So maybe it's 15 minutes, maybe it's at every hour, maybe it's once a second. They'll give you this power and energy data, but I have no context within these views of whether or not this is up to my modeled capacity. If it exceeds my modeled capacity, what that would mean for me financially. Does the utility curtail at that point, or do I earn extra money on this project? Or if it's lower than it was modeled, why? Is it because the irradiance is lower than what we had put into our initial model, in which case I would like to see a dynamic model updating based on real irradiance? Or is it because of something like we were seeing on the ASU project where the tracker was stuck and having a remote capability to reset it brought us back to a more optimized energy output? So that kind of context on what's happening, why is it happening, and what can I do to improve what's happening is missing in the analytics that we have available to us today. And then when we talk about inefficient action, this is really the ability to do something about what data you have, what analytics you have. An example that I recently read about as an area for investigation in how cities work is that the noise pollution in cities is starting to be studied as a real problem for many people who live in cities. And one area where we could reduce this is with fire truck sirens, ambulance sirens, police sirens, and being able to tap into the intelligence that now exists in so many modern cars. If a fire truck could send a remote signal to a car that's in front of it and override that car's stereo system, then they could direct their siren only to the car's interior that really needs to know about the problem and not blast out their siren across the entire city. This, though, creates cybersecurity issues. Now you have your public infrastructure capable of overriding car functionality. That needs to be very carefully done in order to not put your citizens at risk. When we look at this in solar, we see two problems. Our energy grid is vulnerable, but at the same time, any security solutions that are put in place today are decoupled from an optimized workflow. So the way that this is done now is controls are limited to a network operations center, and only people within the NOC are allowed to actually make some sort of control on the project site. And first of all, this doesn't really solve the cybersecurity problem. There are still many, many ways that this is hackable, one being just the network communications on a project site. If you go to the very basic level, that those wireless communications can be hacked. But additionally, now you have created this constraint on your team. In order to do their job, they have to be inside of the NOC. And that makes it very difficult to find efficiencies and continue to reduce the cost of O&M and life cycle costs of these solar projects. So now if we talk about some of the solutions, what we do at SunLink is we don't try to reinvent wheels. We really try to learn from different industries on different applications that have been successful, and then find ways that we could use those technologies in our space. So we look to the technology world for some of the solutions that they have found to these different problems. This is what we call MTech convergence. It's really a focus on interdisciplinary thinking. So when we talk about going from data to information, no longer having siloed databases, no longer having siloed people thinking about data in their specific vertical, but really crossing over and looking at things in a more holistic manner, RESTful APIs are what help automate this. So rather than having a person go and manually look for what is this piece of data I need, and now let me manually enter it into my data set, you have things like the NREL Developer Network, which is my personal favorite, as we have pulled this into our Vertex platform, that in order to do that dynamic modeling update, that we're not looking at just the PV-SIST or the PV-WATTS or any other model at its initial project development, but that we can really continue to update this model based on real-time irradiance. We can also pull in direct normal irradiance, average global horizontal irradiance from NREL's data sets and use that as a comparison to see how we're doing against that. And we don't have to pull that data by manually looking up where my project location is, but we can automate the entire process through the API. So the command is literally one line of code that says, get my direct normal irradiance data for this project location, and it automatically then feeds into all of the modeled behaviors of the systems. When we talk about visualizing and understanding these projects and really doing some solar-specific analytics, that's important, but we also see an openness that tech has adopted as being essential to leapfrogging innovations and going far beyond what any one person or any one company can do creatively. So getting developer access in order to expand capabilities is essential in terms of really furthering the industry faster than anyone can do. So when we talk about this, the way that SunLink has approached it with Vertex is having kind of some areas where where we've started off with some widget tools in order to look at analytics. In this particular case, we have the portfolio views, so portfolio intelligence, which is this project level view that Jonathan went over, where you can see each project's size based on its energy contribution to the overall portfolio, and then each project's color based on its percentage of performance versus modeled, and really hone in on what projects need your attention. You can also see portfolio level energy roll-up of the entire thing. That's a beginning. With having everything on a RESTful API with our platform the way it's developed, developers can expand these capabilities and invent new widgets that we could also do in terms of the portfolio level view, as well as the project level. These are our project widgets that we've started out with our first version of Vertex, where we have project intelligence, project energy, project efficiency, and some project metrics, again, fully extensible based on the creativity of developers and of your own team for what we could put out there. When we look at electrical efficiency, this is the project layout and being able to separate out the different inverter blocks and see how each inverter block is performing at any one time, as well as the tracker arrays. If your particular site has tracker arrays, to really go into the details of each of those and then directly understand trends, understand the data of how this system is performing. And then when we talk about targeted remote improvements in solar, it's fairly straightforward with wanting to have SCADA capabilities, but again, not decoupling that from modern workflows. So allowing remote SCADA from your phone, whether that's on the inverter, on the network switch, on anything else that we would want to control, on the tracker array, being able to remotely set those set points in order to perform how you want, not only optimizes performance in real time, but it also sets our platform up to be able to participate in power markets, to be able to do some really interesting things with smart grids, demand response going into the future by building out the cybersecurity to enable this dynamic control capability. So going into a bit more detail on what's needed in today's solar market, as Jonathan spoke of the different people who are stakeholders in this process, you have a developer that really cares about their portfolio business intelligence and their energy versus modeled, an EPC that needs the fastest time to grid connection and lowest project costs, an O&M team who really cares about having the fewest number of truck rolls and the highest uptime, and an owner who cares about optimized energy and the potential to participate in power markets. Each of these stakeholders wants higher energy yield and lower cost, but it's in the spaces between that we really see a lot of challenges, because budgets are intolerant of custom solutions, and solving for project lifecycle exceeds most platform capabilities. So what we looked at in developing Vertex were these spaces between. So between the owner and the developer, it's a portfolio intelligence that's needed. Between the developer and EPC, it's the performance guarantees. Between the EPC and the O&M company, it's geospatial context for their alarms and events. And between the O&M and owner company, it's this remote control capability. And so then the really underlying foundational elements of this are the cybersecurity to facilitate remote controls and the data context to push the analytics of our solar projects far beyond what they can do today. So with that, if you are interested in a demo of the Vertex Project Intelligence Platform, register at sunlink.com/vertexdemorequest, and we'd be happy to contact you to schedule either a kind of one-on-one webinar or an in-person demo and play around with what our capabilities are. We also have a training center in San Leandro with both our mounting system products as well as kind of an overview of the services that we provide through our Power Care Services arm. And then also we have Vertex hooked up to some of our own systems and our own demo projects, so we can show you some of those capabilities as well. So contact us if you'd like to come out and visit. And then we're going to pass it back to George to help us work through some of the questions.
All right, well, thank you both Kate and Jonathan. That was extremely informative. The first question that we're going to tackle here, can you integrate other tracker manufacturers into this platform?
Yeah, I'll take that one. So, yeah, the intent of the Vertex platform was not to create something that was only for our own products. It was to create an open platform that would integrate other tracker systems, inverter systems, and and to create something that was, somewhat standardized in application.
Thank you, Jonathan. The next question we have here from our audience is, what hardware do you supply as part of the Vertex offering?
This depends on the project application and how far a customer wants to go in terms of their cybersecurity and their diagnosing capabilities. So what we automatically supply on every project is a typical SCADA hardware package, so plant controller, remote intelligence gateway, the things that you would come to expect from a SCADA solution. And then beyond that, we have an additional element of our security that does tokenization between components on site, so that when I spoke of the risks of wireless communication and how that could be a problem on different projects, we have that solution, but it is hardware enabled in order to do tokenization between devices, and so that would be something that would be optional if the project scope allowed.
Okay, great. Thank you, Kate. Another question here from our audience. Can energy storage or frequency regulation be incorporated into this platform?
Yeah, so going back to my earlier comment, the idea of Vertex as a platform is to serve as that connector between the utilities and various other technologies that will increase the penetration of renewables onto the grid. So the shorter answer is yes. There are a lot of energy storage companies out there in the market, and they all have their own platforms. But if you want to benefit from whether it be peak shaving or demand response or things like that, there's going to have to be one platform that they can work within, and that has to be an open platform. So the short answer is yes, and the functionality as we start to see more and more of this technology will be incorporated into the Vertex system.
Great. Thank you, Jonathan. I think we have time for one more question. We're actually just a minute past our allotted 30 minutes, but the last question that we'll cover for today, what security features do you have that other monitoring providers don't offer?
That's a great question. Security to us is very fundamental in what we're trying to do and the direction that we're trying to take. So when we talk about security, there are different elements of this. There's the capability to do mobile commands, which requires two-factor authentication. So one example of this would be of someone else who has implemented two-factor authentication would be like if you log into Salesforce from a new device, then it requires you to get a password sent to your email in order to prove that it is truly you, a level beyond just your password. We'll have that when you try to make any control commands. So the ways of implementing that can vary. On an iPhone, which is our first release of Vertex is through iOS in the App Store. You can use your thumbprint and the biometrics in order to do that two-factor authentication. Different devices will have different limitations. So we'll have a kind of a suite of options on that front. And then also, as Jonathan spoke about, air gapping the public cloud from the private. The public cloud is where data lives, which doesn't mean that data is all public. It just means it's something like an Amazon web server that has a different level of security than a private cloud, which is really locked down and impenetrable. So the data and the controls are segregated in the hardware of the actual servers. And then again, when we talk about on-site communication between devices and authenticating that a device is actually a device on the network and not someone trying to hack in remotely through wireless connections, then that's where we have the tokenization solution in order to prove at any time that a device wants to give data or that a device is taking a control command that it is in fact the device that it says it is.
Excellent. Thank you, Kate. At this point, I'd like to thank all of our attendees for coming today to our webinar. Thank Jonathan and Kate for the wealth of knowledge. And if we didn't get to your question today, we will follow up with you individually via email. And again, thank you very much.